Okay, today we're looking at lesson 6.3, which is solving equations by factoring. Factoring is going to be more exact than lesson 2 when we were doing the graphing, because we had to estimate in lesson 2. But factoring, we're going to use our techniques from chapter 5, section 4 of factoring. We're going to start off by looking at problem number 19 here, which is x squared minus 4x equals 21. In order to go in and factor, we need to have everything on one side, so we're going to move that 21 over by subtracting it. I get an x squared minus 4x minus 21 is equal to 0. In lesson 5.4, we asked ourselves, is there anything common that I can pull out? This quadratic does not have anything common to pull out, so I'll try to go into binomials. There's only one way to get an x squared that we're going to use, and that'll be an x and an x. Because my last sign is a minus, it means I'm going to have one of each sign, one positive, one negative. Two numbers that multiply to give me 21, but when I subtract them, because my signs are different, I get 4, would be 7 and 3. So I'm going to put the 7 with the minus, put the 3 with the plus, do a quick check with your FOIL, get an x squared, a negative 7x, a positive 3x, I get my negative 4x, and then 3 times negative 7 is negative 21, it checks. Now that I have it factored, I take each of the factors and I set them equal to 0, and I solve it. Adding a negative 3 to both sides, I get x equals negative 3. Adding a 7 to both sides, I get x equals 7. So my solutions would be negative 3, 7 for that problem. Plug them in, check it, make sure it works. 21, same idea. You have to move everything to one side. So if I add a 3x to both sides, I will get a 4x squared plus a 3x is equal to 0. Again, ask yourself, is there anything like that I can pull out? When I look at it, I see I have an x in each term, so I'm going to pull an x out. When I factor the x out, I'm left with a 4x plus 3 in parentheses. Now I have two terms, an x that will get set equal to 0, which is already solved, and the 4x plus 3 will get set equal to 0. Subtract a 3 from both sides, I get 4x is equal to a negative 3. Dividing both sides by 4, x is equal to a negative 3/4. So my solutions here, the roots, the x-intercepts, is 0 and negative 3/4. The next two problems I want to look at has us having where we're given the roots and we want to go and write a quadratic equation. The directions say write a quadratic equation with the given roots. Write the equation in the form of ax squared plus bx plus c equal to 0, and you have to have integers for your a, b, and c. Now when you're going to go and do this, you're going to always follow the general rule of binomial x minus a times binomial x minus b. So when I'm going to go in, I'm going to take my first problem here, 35. I'm going to take x minus a negative 2 and x minus 7. Simplifying it up, I have x plus 2 times x minus 7, and now I use my foiling technique that we had in algebra. We reviewed in chapter 5. Foiling, my first terms are x squared. My second, the outside terms are a negative 7x. The inside terms are a 2x. And the last terms are a negative 14. Collecting my terms, I get x squared minus 5x minus 14 equal to 0. Don't forget to set it equal to 0 because it asks you for an equation. Equation needs a left and a right with an equal sign. Problem 39 is very similar in that we're given two roots, but one of them is a fraction, so we're going to have to work at eliminating the fraction when we're done. Still follow the same rule of x minus a, so I'm going to take x minus 1/2 and x minus 3. Go ahead and FOIL. First terms are an x squared, outside terms are a negative 3x, inside terms are a negative 1/2x, and last terms become a positive 3/2. Now at this point, because I have those fractions in there, I'm going to use a technique we had earlier this semester, and I'm going to multiply everything by 2 so I can eliminate those fractions, because we want integers. Multiplying everything by 2, I get a 2x squared minus 6x minus 1x plus 3. Collecting my like terms, I come up with a 2x squared minus 7x plus 3 is equal to 0 because I asked for an equation.